The year was 1977. The world watched as two spacecraft embarked on an epic journey. These were Voyager 1 and Voyager 2. Their mission? To explore the outer planets of our solar system. This was a bold and ambitious goal. No spacecraft had ever ventured so far before. The Voyagers were launched on a trajectory to take advantage of a rare planetary alignment. This alignment occurs only once every 176 years. It allowed the spacecraft to use the gravity of one planet to slingshot them towards the next. This gravity assist technique saved fuel and time, enabling the Voyagers to reach their distant destinations. The twin spacecraft were marvels of engineering. They carried a suite of scientific instruments. These instruments would allow them to study the planets, their moons, and the space environment in unprecedented detail. The Voyagers were also equipped with a special package. It contained messages and sounds from Earth. This was the golden record, a cosmic time capsule intended for any intelligent life that might find it. The launch of the Voyagers marked the beginning of a new era in space exploration. It was a testament to human ingenuity and our insatiable thirst for knowledge. The Voyagers were about to embark on a journey of discovery that would forever change our understanding of the solar system and our place within it. The Voyager spacecraft were designed to withstand the rigors of deep space travel. They are built like tanks. Each spacecraft weighs nearly 2,000 pounds and is about the size of a small school bus. At the heart of each Voyager is a three-axis stabilized platform. This platform keeps the spacecraft's instruments and antenna pointed in the right direction. 3 radioisotope thermoelectric generators, or RTGs, power the spacecraft. These generators convert the heat from decaying plutonium into electricity. This power source provides the energy needed to keep the Voyagers operating in the cold, dark depths of space. Voyager's scientific instruments include cameras, spectrometers, magnetometers, and plasma detectors. The cameras capture images of the planets and their moons. Spectrometers analyze the composition of planetary atmospheres and surfaces. Magnetometers measure the strength and direction of magnetic fields. Plasma detectors study the charged particles in the solar wind. Voyager also carries a special instrument called a cosmic ray detector. This instrument measures the high-energy particles that constantly bombard our solar system from interstellar space. These instruments provide a comprehensive view of the planets, their moons, and the space environment. The Voyager's primary mission was to conduct a grand tour of the outer planets, Jupiter, Saturn, Uranus, and Neptune. This was a once-in-a-lifetime opportunity to study these gas giants in detail. Voyager 1 would focus on Jupiter and Saturn. Voyager 2 would visit all 4 gas giants. The spacecraft followed slightly different trajectories. Voyager 1's path was optimized for a close encounter with Saturn's moon Titan. Voyager 2's trajectory allowed it to continue on to Uranus and Neptune after its encounter with Saturn. The Voyager's journeys were not without challenges. The spacecraft had to navigate through the asteroid belt. They faced extreme temperatures and radiation levels. But the Voyagers persevered, sending back a treasure trove of data that revolutionized our understanding of the outer solar system. The Voyager's discoveries were nothing short of groundbreaking. They revealed the intricate details of Jupiter's Great Red Spot. They discovered active volcanoes on Jupiter's moon Io. They found evidence of liquid water on Saturn's moon Titan. And they captured stunning images of Uranus's rings and Neptune's Great Dark Spot. Voyager 1 reached Jupiter in March 1979. Voyager 2 followed close behind in July 1979. The spacecraft spent several months studying the gas giant and its moons. They sent back stunning images of Jupiter's swirling clouds. These images revealed the complex dynamics of the planet's atmosphere. The Voyagers discovered that Jupiter's Great Red Spot is a massive storm. This storm has been raging for centuries. They also found that Jupiter has a faint ring system. This ring system is much fainter than Saturn's rings. One of the most surprising discoveries was the volcanic activity on Jupiter's moon Io. The Voyagers observed 9 active volcanoes on Io. This made it the most volcanically active body in the solar system. The volcanoes on Io are powered by tidal heating. This is caused by the gravitational pull of Jupiter and its other moons. The Voyager's observations of Jupiter and its moons provided scientists with a wealth of data. This data helped them to understand the formation and evolution of gas giants. They also learned more about the complex interactions between planets and their moons. After their encounters with Jupiter, the Voyagers continued on to Saturn. Voyager 1 reached Saturn in November 1980. Voyager 2 arrived in August 1981. The spacecraft's instruments revealed the intricate structure of Saturn's rings. They found that the rings are made up of billions of individual particles of ice and rock. The Voyagers also discovered new moons orbiting Saturn. These moons were previously unknown. One of the most intriguing discoveries was the moon Titan. Titan has a dense atmosphere. This atmosphere is rich in organic molecules. The Voyager's observations suggested that Titan might have lakes and seas of liquid methane. The Voyager's encounters with Saturn provided scientists with a wealth of data about the ringed planet. They learned about the composition and structure of the rings. They also discovered new moons and learned more about the planet's atmosphere and magnetosphere. Section 6, Uranus and Neptune, Ice Giants Unveiled. Voyager 2 continued its journey to Uranus and Neptune after its Saturn encounter. It was the only spacecraft to visit these ice giants. Voyager 2 reached Uranus in January 1986. It discovered 10 new moons and 2 new rings. The spacecraft also found that Uranus has a tilted magnetic field. This magnetic field is offset from the planet's rotational axis. Voyager 2 reached Neptune in August 1989. It observed a massive storm in Neptune's atmosphere. This storm was dubbed the Great Dark Spot. The spacecraft also discovered 6 new moons and 4 new rings. The Voyager's encounters with Uranus and Neptune provided scientists with their first close-up views of these ice giants. They learned about the planet's atmospheres, magnetic fields, and ring systems. They also discovered new moons and gained a better understanding of the outer solar system. Section 7, A Message in a Bottle for the Cosmos. In addition to their scientific instruments, the Voyager spacecraft also carry a special message. This message is for any intelligent life that might find them. This message is known as the Golden Record. The Golden Record is a 12-inch gold-plated copper disc. It contains sounds and images that portray the diversity of life and culture on Earth. The record includes greetings in 55 languages, music from different cultures, and sounds of nature. It also has 115 images encoded in analog form. The content of the Golden Record was selected by a committee chaired by the astronomer Carl Sagan. The committee wanted to create a message that would represent humanity as a whole. They hoped that the Golden Record would one day be found by an alien civilization. If found, it would provide them with a glimpse of life on Earth. Section 8, Voyagers in Interstellar Space. After completing their primary missions, the Voyager spacecraft continued to journey outward from the Sun. In 2012, Voyager 1 crossed a boundary known as the heliopause. This is the point where the solar wind from the Sun gives way to the interstellar medium. Voyager 2 crossed the heliopause in 2018. The Voyagers are now in interstellar space. This is the space between the stars. They are the first human-made objects to reach this region of space. The spacecraft continue to send back data about the interstellar medium. This data is helping scientists to understand this unexplored region of space. The Voyagers are powered by their RTGs. However, the power output of the RTGs is gradually declining. To conserve power, engineers have been turning off some of the spacecraft's instruments. Even with these power-saving measures, the Voyagers are expected to run out of power sometime in the 2030s. Once they run out of power, they will no longer be able to communicate with Earth. Section 9. A Legacy for the Ages. The Voyager missions are among the most successful and inspiring space missions in history. The spacecraft have traveled farther and lasted longer than any other spacecraft. They have revolutionized our understanding of the outer solar system and provided us with our first glimpses of interstellar space. The Voyagers have also captured the imagination of people around the world. Their epic journeys have inspired generations of scientists, engineers, and dreamers. The Golden Record stands as a testament to our humanity and our desire to connect with other intelligent life in the universe. The Voyager spacecraft will eventually fall silent, but their legacy will live on. They will continue to drift through the galaxy as silent ambassadors of humanity. They carry with them a message of hope and curiosity. This message will continue to inspire future generations to explore the cosmos.